Sense multiple access protocol. This is another protocol which is existed in the random access protocol. So we'll see what is this carrier sense multiple access protocol and what are the types of CSMA protocols are there. So in CSMA we have the carrier sense multiple access protocols are there, and CSMA CD, carrier sense multiple access collision detection, and CSMA CA, carrier sense multiple access collision avoidance. So here in this concept we will discuss all these three: carrier sense multiple access protocols, CSMA CD and CSMA CA. So we'll see what is carrier sense multiple access protocols first. So carrier sense multiple access. So the name itself indicates carrier sense multiple access. So whenever the multiple access is there, that means more number of station want to access the same channel, then here it needs the sensing of the carrier. So what is the sense of the carrier? So before transmitting the data, the stations need to sense the carrier whether it is in busy state or it is in idle state. So what is the purpose to sense the carrier? So what is the main purpose to sense the carrier? When multiple accesses are there, so more number of stations want to access the same channel, then there may be a chance of collisions will occur. To avoid those collisions, first we need to sense the carrier whether it is busy or in ideal state. So if the carrier is in ideal state, then simply the station starts transmitting the data. Otherwise, it will wait for some time. So here different type of protocols are there used in a different manner, means different mechanisms, so for sensing the carrier. So why this CSMA was developed? So CSMA was developed to overcome the problem found in Aloha protocols. So in Aloha protocols, we found some disadvantages. So to overcome that problems in Aloha, the CSMA protocol was developed or introduced. So why this CSMA protocol was developed? To improve the performance or to minimize the chances of collisions which occurred in the Aloha. To give solutions for that, this CSMA protocols was developed. It is mainly based on the principle of carrier sense. So the main important thing in carrier sense multiple access is carrier sense only. The chances of collision can be reduced to great extent if a station senses the channel before trying to use it. So before trying to use it, if the station senses the channel, then it will reduce the chances of collision. It will reduces the chances of collision. Although CSMA can reduce the possibility of collision, but it cannot eliminate it completely. So by using the CSMA protocol, it completely eliminates the collision. No, it cannot completely eliminate the collisions. The probability of or the possibility of collision is reduced when compared to the Aloha protocols, but not completely eliminating the collisions. So here is the definition for carrier sense multiple access. So what is carrier sense multiple access? Shortly we called it as CSMA. CSMA is a network protocol that listens to or senses networking signals on the carrier or medium before transmitting any data. It is implemented in Ethernet networks with more than one computer or networking device attached to it. It is the part of medium access control protocol. So this is one of the part of medium access control protocol. It is a definition of the carrier sense multiple access. So here is small example. So here we have four stations are there: A, B, C and D, and timeline is also represented here like this. So these are the timelines for stations. So at time T1, A starts transmitting the channel, means before sending the data, the stations will sense the carrier. So this is the propagation time. So in this propagation time of a particular channel, the station B senses the channel here, and the station C senses the channel here, and the station D senses the channel here. So like that, at that particular time of that particular station, it sends the channel. So here the vulnerable time means the vulnerable time Vt is considered as the propagation time. So in the previous cases, we saw what is vulnerable time in pure aloha and what is vulnerable time in slaughtered aloha. So in pure aloha, we have two TT, and in slaughtered aloha, it is TT, small t. So like that, here the carrier sense multiple axis vulnerable time is propagation time. So here is the small example for how the stations will sense the carrier. So here the persistent methods can be applied to help the station take action when the channel is busy or idle. I already told, here we will apply some persistent methods to sense the carrier. So three different type of persistent methods are there. So one is one persistent CSMA, non-persistent CSMA, and P-persistent CSMA. These three are three different methods for sensing the carrier. So we'll see one by one. We'll see the first one, that is one persistent CSMA. So the definition of one persistent CSMA is, it is called one persistent because the host transmits with a probability of 1. So that the host means the sending station, means the transmission station transmits with a probability of 1 whenever it finds the channel idle. That's why the CSMA is called as one persistent CSMA. While there is a new frame A is sent, then how the steps will taken. So here in one persistent CSMA, we will follow a step-by-step manner called algorithm. So what is that mean? In the first step, we need to check the medium. So why we need to check the medium? We need to check the medium whether it is in ideal state or in busy state. So for example, if the medium is in busy state, then what we'll do? So if the medium is in busy state, then simply go back to the first step. Go back to the first step. What is that first step? Check the medium again. So if the channel is busy, then simply go back to the step 1. So what is the step 1? Check the medium. So until the channel is idle, we need to continuously check the medium, whether it is busy or idle. So if the channel is idle, if the medium is idle, then what we'll do? Send frame A and wait for the acknowledgement. Send frame A and wait for the acknowledgement. So if after some time, for example, acknowledgement is not received. So after some time, if acknowledgement is received, then it is good because the transmission is successful. If the acknowledgement is not received, then the sender waits for some time. What is that time? If timer times out, then what will do? It wait a random amount of time and go to step 1 again. So if the acknowledgement is not received in a stipulated time period, then it will wait for a random amount of time and go back to the step 1 again. So because the data is not transmitted successfully, that's why again it needs to send the data. So if it wants to send the data, what it will do? First it will check the medium. That's why if the acknowledgement is not received in the stipulated time period, simply it will wait for random amount of time, and after that it will go back to the same check step 1. So after that it is completed. If for example, while transmitting the channel, if collision occurs, so what we'll do? If collision occurs, then it will wait for a random amount of time and start over again. So here is the case, means there is a possibility of collision occur also. So how it will occur the collision, means even though we will sense the carrier, why the collisions will occur, we'll see in the later. So here is one persistent CSMA. So what is the working principle of one persistent CSMA? So here, if sender A wants to transmit the data, so this is the timeline. This is the timeline. So in that timeline, the sender, means the host who wants to transmit the data, it simply continuously sends the channel. So continuously sends the channel until the channel is idle. Until the channel is idle. So see here, it is a busy channel, means the timeline, the channel is busy with some other station. So when some station, means when transmitting station wants to transmit the data, it simply continuously sends the channel until the channel is idle. If the channel is idle, then simply it transmits the data. So this is the working principle of one persistent CSMA. So we'll see the flow chart for this one, how it will works. So here is the flow chart for one persistent CSMA. So here the station is there. So station checks the channel, check the medium or channel here. So if the channel is busy, if the channel is busy, simply it go back to the first step again. If the channel is idle, then the station can transmit the data. Clear? So here the station checks the channel. If the channel is busy, then go back to the same, means here go back to the first step again. So if the channel is idle, then the station can transmits the data. Clear? This is the flow chart for one persistent CSMA. So here one persistent CSMA is having some advantages and disadvantages. So what is the advantage of one persistent CSMA is it has better throughput than Aloha protocols. So when compared to the Aloha protocols, it is having a better throughput. Means when compared to the Aloha protocol, by sensing the carrier, here we will reduce the occurrence of the collisions, the possibility of the collisions. So if the collisions, if we reduce the number of collisions, then automatically the throughput, the efficiency is improved. So efficiency is nothing but throughput. That's why one of the advantage of one persistent is it has the better throughput than Aloha protocols. And every protocol is having two sides, one is advantage, another one is disadvantage. So here also for one persistent CSMA we have the disadvantages. So what are the disadvantages for one persistent CSMA? There are two different chances, situations for occurrence of the collisions. Two different cases are there. So what are the two different cases? So first one, if station A has transmitted a frame which has not yet reached another station B due to the propagation delay. So for example, A starts transmitting the data, but due to the propagation delay, it is not yet reached at the another station B. So what B will think? So B assumes that the channel is idle because station A already transmits the data, but due to the propagation delay, it is not reached to station B. So station B assumes that the channel is idle. So what B will do? So it simply transmits its frame. So station A already transmits the packet and station B also transmits the packet. So it leads to collision here. So due to the propagation delay, so it leads to collision. This is one of the case. This is one of the case for chances of collision. Another one is, suppose that a station A is transmitting while station B and C are waiting for transmission to complete. At the instance, Station A completes transmission. Both station B and C start transmitting simultaneously at the same time. So three stations are there. Station A is transmitting while station B and C are in waiting state. So station B completes its transmission. So the duty of station A is completed. But station B and station C starts transmitting the data at the same time. So here also there is a chance of collision will occur. So like that, even though we are sensing the channel, there may be a chance of collisions will occur. That's why the CSMA is not for complete elimination of the collision process. Here we just reduce the chances which are occurred in the Aloha protocol. So Aloha protocols, we reduce the collisions by using slotted Aloha. So in slotted Aloha also there may be a chance of collisions. So to that particular collisions means to reduce that number of collisions, we will use this one persistent CSMA. So even though one persistent CSMA is used, the two or more cases are there like this to the occurrence of the collision. So to avoid this, we will move to the next persistent method, that is called as non-persistent method.